Thank you for attending this CIBSE approved presentation on the SCA Guide to Common Escape Routes. My name is Alan Hurdle and I act as a technical consultant to the SCA. Today I intend to give you a taster of the updated SCA Guide to Common Escape Routes in apartments, buildings and the standards that should be worked to with the key products used in smoke control systems. The guide itself is far too big to cover in one presentation, having over 79 pages. So we will be looking in particular at the products used in smoke control systems and the standards that they should comply with, which include the BS and EN standards that the smoke control system has to follow for both competence and for compliance. The SCA are at the forefront of smoke control, making use of CFD design, independent testing of natural and mechanical smoke ventilation products, with CE markings, along with concise and clear system installation procedures, which are followed by competent contractors and engineers approved under the IFC SD119 competence scheme for smoke control designers and installers. A number of methods contained in the SCA guides have been adopted by BSI in the BS 7346 range of standards and the EN 12101 European Standard Series. Currently, SCA projects include an update to Computational Fluid Dynamics or CFD guide, together with forging closer links with the British Automatic Fire Sprinkler Association and the FSF, with the common aim of saving lives. So you are aware, the original SCA guide was produced in 2010 to support and to assist those companies and individuals involved in smoke control system designs. It has now been updated to take today's needs into account and the lessons learned over the last 10 years as buildings have changed and designs have become more complex. This presentation gives a summary of this guide, but you can review with full details of the guide by visiting the SCA website, and the details are shown at the end of this presentation. Part of the development of this guide were members of the National Fire Brigade, UK consultant engineers and fire consultants, plus competent smoke control designers, installers and manufacturers. Their input has been invaluable in preparing the guide, ensuring not only building residents' needs are taken into account when an unfortunate fire takes place, but also those of the fire crews who attend the fire when requested. Many of the buildings inspected by the fire brigade has poor systems and components that did not operate in the manner intended or had not been serviced and maintained, which is compulsory for all life safety systems. In addition, a number of building operators had limited or a lack of understanding of how their smoke system works. Well, these alarming figures further outline the importance of the SCA Installer Certification Scheme, which focuses on training, competence, certified products, the system, and the service and maintenance. The primary objective of the guide is to raise awareness and understanding, thereby giving a form of protection to the stairwells in times of fire, thus allowing a means of escape when lifts are out of use. It allows the fire team to get to the seat of the fire without vision being impaired and a restriction of the equipment to be used. The guide is a document that building designers can refer to for advice on smoke control designs for various building types, with corridors that do not exceed 7.5 metres for natural ventilation systems, or 15 metres if sprinklers are fitted. Distances for mechanical smoke shaft systems can be greater and cover smoke shafts, automatic opening vents or AOVs, lobby and corridor ventilation. It should be remembered that not only is there natural ventilation systems, but also mechanical ventilation for buildings, driven by ventilation smoke removal. Others include pressurization, passive or natural system designs, and all dependent on the building location, closeness to other buildings, the wind condition, building heights, and building types. All these systems have their place when reviewing a ventilation smoke control and smoke removal system. When designing a ventilation and smoke control system, the fire engineer will look at various scenarios, but the primary objective is always around smoke removal for keeping areas clear of smoke and assisting in saving lives in times of fire. To this end, consideration should be given to the areas requiring smoke controls, such as the stairs, the lobbies, corridors, and hallways. The following slides show the layouts of a typical building's work shaft, followed by products that would be installed in the system. This schematic drawing is a typical stairwell arrangement, together with its purpose, its products associated with controlling and forcing smoke into the builder's workshaft away from the stairs and the lobbies. Guidance is given in Approval Document B, BS 9991 and in BS 7346 Part A. Leakage tests before product installations are important to ensure the system works correctly as specified, coupled with regular service and maintenance. And here on this slide, you can see the location of the smoke products from dampers, controls, and extract fans. Products associated with a smoke control system include natural smoke ventilators, which must be independently tested and certified with CE markings. It is important that any building design engineer, when reviewing the smoke control system, only specifies products that have been independently tested and comply with the relevant BSEN standards, plus have access to the product test certificate and DOP or declaration of performance. It is not acceptable to estimate or guess the free area or aerodynamic areas of natural opening smoke ventilators, as this could have a major impact on the smoke control design. It is important that sizing is based on the free area that has been measured accurately and following the relevant guidance or measured under test. Another product utilised within a smoke system are smoke control dampers, often utilised in smoke shaft. These are generally mechanically controlled via an actuator as compared to a natural opening ventilator. These supplied products should follow clear tests and certification requirements to the EN 12101 Part 8 2011. It is no good having a product shown as manufactured and tested in accordance with. They must have an independent test cert with a declaration of performance. When considering smoke dampers, you have to understand that they have two safety positions. One is for smoke extract and one fully closed to stop smoke entering the areas that are part of the means of escape. Therefore, they form part of the fire compartment. Smoke and fire detectors are connected to sense the smoke and allow the dampers to react according to the conditions they find. Smoke shaft dampers, well, this has long been and still is a major grey area in the smoke control industry, as it is technically possible to comply with approval document B using a fire door with an actuator fitted to it on site. However, there is no product standard for this and no independent testing carried out to ensure quality of the solution. The new guide from the SCA recommends fully tested and certified damper and flap products to the EN 12101 Part 8. And the SCS is lobbying for the approval document B to be clarified to this effect. Fire dampers marked EN 15650 but fitted with separate actuators or replaced with other suppliers' actuators are not recognised or will not be CE marked. Again, the SCI only recognises dampers and actuators as a system that is tested together. EN 12101 Part 8 is a harmonised standard that should be adopted for all damper products. The relevant harmonised standards should be utilised and it should be enforced. Within the product testing, a number of other tests are carried out alongside the high temperature tests. The products used have to meet a number of conditions to ensure they continue to perform as specified when used in both a standard and a fire situation. And here on this slide, it shows you the sorts of tests carried out for natural smoke vents, powered heat fans, and smoke dampers. When looking into other parts of a smoke system, then ducting comes into play. And we'd say that only fire-rated ducting to BSEN 12101 should be used as part of the smoke control system. Ducting itself has its own suite of standards and is dependent upon the ducting application, and they should be specified against the requirements of the system design. The standards to the BSN are shown on the above slide and are especially designed to BS 7346 Part 8, where guidance can be obtained. Control equipment is now part of today's technical requirements supporting the building management system. Controls play a major part, often linked to the BMS and fire alarm system. It is important as it can identify for the fire teams where the fire is located and the condition of the equipment and what elements are operating. These controls should be regularly inspected to ensure they are performing and monitoring as originally designed and still fit for purpose, which also covers the cables and the system status. The firefighter's controls has to be simple and easy to operate under extreme conditions. They should not give rise to complicated instructions for firefighters, and they should comply to the ISO 21927 Part 9 with a specific RAL colour for opening and close switches. Location of the firefighter's control is also important, so that the fire team know where they are located, and the height fitted at 1.8 metre above ground does not give rise to tampering for false alarms. Power supply equipment for smoke and heat control rely on sensors and should be CE marked to conform with the BSEN 2101 Part 10. Alternative power supplies are required for smoke control systems, and they work together by means of an automatic transfer switch. Control panels should be located outside the fire zone, together with the power cable, the fan control panel, with the enclosure fire resistant for 60 minutes. That ensures that the smoke system continues to work or be isolated in times of the fire in support of the fire teams. Whilst there is no requirement for a firefighter's central control panel with monitoring facilities for residential buildings, in some complex projects, they may be useful in showing the fire services the system operational status. So we would also recommend this panel as being something to be added to a smoke control system. Mechanical ventilation fans are used in a number of applications for building ventilation. Mechanical high temperature smoke fan extract fans are manufactured to a higher standard than ambient temperature fans for motors, cables and impeller tip clearances. In general, HT fans are manufactured to run at 300 degrees for 2 hours as required in EN 12101 Part 3. They are independently tested at this temperature with a 1 hour run up, a 2 hour HT test and a 1 hour run down process before an independent certificate of performance is issued by a typical test house such as BSRIA. Standard ambient temperature fans should never be fitted for smoke removal due to the hot temperatures of smoke and a fire. Regular service and maintenance should be carried out in line with the fan manufacturer's guidelines and service procedure. At times, a fan manufacturer may recommend the fitting of a specified inverter to control the fan speed for better motor speed control. Only the fan manufacturer's recommended inverter should be used, as these will have been independently tested together to ensure compliance to the system it was designed for, and tested together to the relevant EN standard with the relevant CE mark and declaration of performance. A major importance to a fire engineer design is the cable from the control system to the mechanical fans and dampers. This is because the failure of the cable will result in a breakdown of the smoke control system. Cables to category 2 as a minimum should only be fitted as shown in this table and is recommended for all smoke control systems. The following slides will give details of the VSEN and ISO standards that should be followed when selecting products as part of a smoke control system, and details of these standards are available on the SCA website for download. As an aid memoir, the following table details all the relevant standards that should be adhered to for the various smoke control products and system used by a smoke control design engineer. This is an important document as it allows an understanding of the various BS and EN standards released. And as mentioned, a copy of this table is available on the SCA website. This second document is used when designing a smoke and fire control cable system. Again, it shows the BS cable standards and their categories. And as mentioned, category 2 is the minimum of an SCA recommendation. And as mentioned before, you can download a copy of this guide from the SCA website. As is clear, working to BS and EN standards play an important part of any smoke control design. A good designer will have made himself familiar with all the standards, or at the minimum have access to the standards applicable to his design. This understanding is an important part of the SCA's independent certification scheme on competence, managed by the IFC for the SCA and other smoke control building system designers and installers. The SCA IFC competence scheme is approved by UCAS and is now truly embedded in the installer members of the SCA and other companies outside of the SCA. For full details of the scheme, including the criteria around SCA membership, can be found by visiting the SCA website. SCA members who design and install smoke control systems are required to apply for and receive accreditation from the International Fire Consultants Scheme as a condition of membership. Companies choosing designers, installers should encourage both to register to a recognised scheme. The IFC scheme is the first independent smoke control scheme having UCAS approval for smoke control systems and will play an important role in supporting the various working groups set up post Grenfell Tower fire. Working Group Zero and the industrial response groups have now recognised smoke venting as part of their review for updating the approval document B for covering competence and compliance for fire safety in line with the Dame Judith Hackett recommendations of the Golden Thread. There now are approximately 45 companies that have signed up to the SDI 19 scheme. As mentioned, all SCA members involved in smoke control design and installation are audited to BS 7346 Part 8 2013 Code of Practice. Under the scheme, random project audits are carried out, coupled to audits on in-house training of designers. This will include audits at the installations on site. As previously mentioned, BS 7346 Part 8 2013 covers components for smoke control systems and offers both technical and procedural guidance, including useful information on certificates for all stages of design. It is referred to in BS 9991 and is included in the EN 12101 suite of numbers. Certificates of competence of system designers and installers should be part of the package of certificates given at the building handover. So in summary, it is common for buildings to be designed with extended travel distances, and therefore features such as mechanical smoke shaft systems are used. The extended smoke design systems are currently not within approval document B, but are fire engineered solutions. And a lot of work has gone in developing the system via CFD modelling to show better performance than natural ventilation. And because some fire engineer solutions are outside of the approval document B, then the SCA guide is an important document used by fire design engineers.